If you're considering putting a central dust collection system into your shop, I'm going to give you some tips here to keep in mind as you go that are going to make things work a little better, work a little more efficiently, so that when you've got a good dust collector pulling air, you're getting optimal performance at the tool. So while I'm leaning on the dust collector here, let's point this out right away. If you've got a big inlet on the dust collector, maintain that large diameter for as much of the run as you possibly can. The larger that main trunk is, the better off you're going to be. Here's an example. If we take 4-inch pipe and compare it to 5-inch pipe, going just 1 inch larger in diameter actually gives us about twice the airflow through that system. So you can imagine if I neck this down from 8 to 4, the difference, the impedance I'm going to be providing to the airflow. So again, stay large as long as you possibly can. Go small when you got to do drops specifically to a tool. Now, talking about drops to tools, that's where you're probably going to start working with flex hose. And like anything, there's flex hose and there's flex hose. So in the perfect world, what I'd like to see is a flex hose that's got metal coils on the outside of the pipe. In this case, these are plastic, so this is not my favorite. The benefit to metal coils on the outside is that I can ground those metal coils so that I'm going to help take static electricity off the system here. What happens is that, of course, as we're pulling chips and dust through the plastic, we're building up a static charge. If I've got metal coils on here, I can ground those, dissipate the static. If you don't have metal coils, you're going to have to take a step to provide a ground in order to dissipate that static charge. What I do like about this pipe is the fact that when I open it up and I put my hand inside, because the coils are on the outside of the plastic, the inside of the pipe, of the flex pipe, stays pretty smooth. So a test you want to do when you're buying that pipe is open it up, run your hand inside there and see how smooth a wall we have. The smoother the wall, the better collection we're going to have, because again, we're preventing, we want to stop stuff from impeding airflow. If this is full of ridges, it's going to impede airflow, it's going to mess with your efficiency. Now, talking about flex pipe, we want to limit its use. Stay with solid pipe as long as you possibly can. Here's the number with that. If I take a 4-foot length of flex, a 4-foot length of solid pipe, this is going to have about 3 times the resistance to airflow that the solid pipe will have. So again, imagine the drop we're getting in airflow, the loss of efficiency at the tool. None of those are things that we want. So limit your use of flex pipe as much as you possibly can. Now, let's start kind of low tech. One option you have is to go to the home center and get standard off-the-shelf HVAC products. This is a 4-inch pipe that when I close that is going to look like this. This is fine for dust collection. A general rule of thumb is that pipe like this is generally recommended for systems using a 2 horsepower or less dust collector. And the reason for this is it's relatively thin walled. So usually HVAC pipe off a home center shelf is 24 gauge, 26 gauge, maybe 30 gauge. Remember that with gauge, as the number gets bigger, the thing gets smaller. So 30 gauge wall thickness is less than 24 gauge. The problem we can run into with a large dust collector is that if it happens that the blast gates all end up closed in the system and we kick on the dust collector, with a thin wall pipe, you can actually collapse the pipe, and we don't want that to happen. So what do we do in that case? One option is what's called spiral pipe. Because of the way this is made, 1, it's a thicker gauge. 2, with its spiral nature, virtually impossible to collapse this stuff. So with a larger system, yes, it's more expensive, but plastic is a good, or spiral pipe is a good consideration. What about plastic? What about using PVC? So PVC isn't a bad option at all. We can get it 4-inch, we can get it 6-inch. It can satisfy a lot of your dust collection needs. What do we already know that we got to take into account? What about this whole grounding thing? If you use plastic pipe, you're going to have to add grounding to it, which is commonly done by just having a wire laying inside the pipe that's then subsequently grounded. That'll dissipate that static charge. That all works great, One of the things I want to point out is not all PVC fittings lend themselves to dust collection. This is a T-fitting, so you might very well say, well, okay, I've got a 4-inch pipe on the ceiling, doot, doot, 4-inch drop. The problem with this is, think of dust coming into the system like cars getting on the freeway. In this case, the car's coming in and has to make a sharp turn. That's not very efficient. In this case, the car is coming in on an on-ramp and can easily merge with the existing traffic. This is what we want. We want merge, not a turn from a stop sign. So using some of these standard PVC fittings is going to limit your efficiency because we don't have the gentle onboarding that we get from dust collection fittings. If you do go with PVC, you don't have to worry about gluing everything together. You can simply screw it together. We have enough friction on those joints. You can screw it together. The benefit to that is if you ever do get a clog in the system, all you have to do is take out the sheet metal screws, open it up, get the clog out, put it back in business again. Now let's go back and revisit our HVAC a little bit. You're probably going to need elbows. And I've got a PVC elbow here as well that's got the same problem these have. The problem being, this is too small a transition. As a general rule of thumb, you want the radius of this elbow to be twice the diameter of the pipe. So 4-inch pipe should have an 8-inch radius. This ain't going to do it, but we can work around this by joining 2 elbows that have been formed at 45 degrees. So net, we get a 90-degree transition, but look at how much larger we've made the radius. So that's what we need to do in order to make sure that that air keeps moving and keeps moving efficiently. Now, if you go this route, one of the things we don't have here is a good airtight system because by the nature of the way these babies work, we spin them to adjust the angle. I would go back and caulk each of these seams after you've got them formed correctly to make sure that each of those seams is correctly sealed. Now, while we've got this in a 45, let's go back and look at our main inlet over here, because there's another consideration is, look how low this is. There's a good chance that our dust collection pipe is going to be up here. And it could be pretty natural that then what you decide to do is, well, I'm going to elbow out of this, not with a 4, I hope, but with a correct diameter elbow. I'm going to elbow out of this, I'm going to go up, I'm going to elbow to the ceiling, I'm going to start to get to my tools. A much better move is a 45 out of this, a piece of pipe. Where's my other 45? There it is. 45 out, piece of pipe, 45 over to get to the horizontal. That's a smoother transition. Again, it's going to keep all your dust flowing, moving better, give you better efficiency in the system. Similarly then, let's keep talking about our HVAC components. Should we use this one or not? You already know the answer to this. Is this a right turn or a left turn, or is it a freeway entrance? So this is a handy T from HVAC systems, but this isn't something we should use for dust collection. Again, we want to provide that on-ramp type setup. When you're stepping down, make sure that your fittings look something like this, where they funnel down as opposed to having a distinct step. This is a much better transition. This is, in this case, from 4 to 3. We want to have this angle transition in between, not a sharp step. This is going to work much better. With the HVAC components, like I said, be sure that you caulk the seams on those elbows when you're done. You can use silicone caulk. They do make specific ductwork sealant that's readily available from a home center so that you can make sure you're good and airtight on these parts. Keep those tips in mind so that once you've got a good dust collector in your shop, you're getting optimal performance out of it at the tools and making sure you're getting all the dust collection that you need and you should get based on the performance of the machine.